A very good afternoon, everyone. I hope that you're doing well. Welcome to week 6 of the semester. And this week we will be continuing on with our syllabus like we have been doing for the past 5 weeks. Now, what we have been doing in CIN603 so far is we are looking at the system development phase of creating an information system within the organization. And the perspective in which we're actually looking at these things is from a system analysis point of view. Okay, it's just that how do we get things arranged so that you can come up with a new system? What are the ways and the procedures of doing things? Now, so far from week 1 till week 5, what we are looking at is we are still in our analysis to design phase. Okay, so we have covered out things on preliminary investigation. That's step 1. Step 2 is system analysis, and step 3 would be jumping on to actually creating the design of the system. So in between system analysis and system design, we end up with something called as the requirements modeling. That means you would go around drawing some certain diagrams, certain form, using certain types of tools to actually see how your system would be up and running. What are some of the things that your system basically and necessarily requires, and how data travels from one end to the system to the other. So that's the major purpose of the entire set of syllabus before your mid-semester break. Now, next week is week 7. Next week, there will be no lectures and no tutorials. Instead, I will be running the class as per the timetable to do some basic revision for your mid-semester exam. By the way, your mid-semester exam, okay, now the quiz, it is in a form of a quiz. It's online based. It opens up on the 5th of September. That means the coming Sunday. Opens at 6 a.m. and then it closes on the following Sunday, which is the 12th of September, 11:59 p.m. Your your mid-semester exam is based on 3 sections. You have multiple choice questions for 20 marks and a time allocation of 30 minutes. You have short answer questions, which also carries 20 marks with a time allocation of 40 minutes. And you have 20 minutes of 10 marks worth of question on object modeling. Now, if you look at object modeling, there are only few things we have covered up in object modeling. We have covered up PERT charts so far, looking at the critical path. Moreover, we will be going over Gantt chart, which is pretty simple, way more simpler compared to PERT charts. So those are the 2 things we have covered up in object modeling, and those would be 2 of the things that will be tested in your mid-semester exam. Right. Moreover, let's go and have a look at your to-do lists for week 6. Okay. Now, for your to-do list for week 6 is very much similar what it is for week 5. Okay, but the only thing that I've inserted in is your preparations for mid-semester exam. Okay, unfortunately, it's not showing in my announcements. Let me quickly have a look. Okay, it's not showing up due to certain reasons. Okay, I'll have a look at that, and probably straight out of the class, I'll try to get that amended and fixed up. All right. Moreover, please also go around focusing on your major project as well. Now, what you can do is, if you feel you have too much things on load at the moment, considering that you have an upcoming mid-semester exam and you're not doing just 1 unit, most of you are doing 4 units altogether. So if you feel it's too much load, okay, you can hold on to your major project at the moment. As soon as you finish up with the mid-semester exam, get your groups active and then start working on your major project. Now, you have approximately 2 months, more than 2 months counting today, to complete this. So try putting in your efforts, try putting in your time dedicated to it. Now, is there any questions or any queries before we move on to the lecture notes? Today's lecture notes is close to about 30 plus slides. Okay, so we'll try to go over it and we'll try to cover it up within 1.5 hours. Any questions, any queries? So those of you who have joined us, thank you very much for putting in your time and your efforts to join us for this class. I appreciate it. If no questions, let's move on. Now, in today's class, it's a continuation from last week's lecture notes. Now, last week's lecture notes, we had definitely looked at the different types of systems that we had altogether. Now, different types of systems or different methods or different forms of diagrams to build up a system. So we looked at class diagram, you looked at use case, you looked at sequence diagram, you looked at state transition diagrams, activity diagrams, and so forth. So this is sort of a continuation from there, but way more brief. So let's have a look at that. Now, the objectives of this chapter is to explain how object-oriented analysis can be used to describe an information system. We'll look at what object-oriented analysis is in the next few slides, define object modeling terms and concepts, including objects, attributes, methods, messages, classes, and instances, explain relationships among objects and the concept of inheritance, draw a object relationship diagram, or ORD as we call it in simple terms, describe unified modeling language, UML, tools and techniques, including use case diagrams, class diagrams, sequence diagrams, state transition diagrams, and activity diagrams. And we'll go around explaining the advantages of using case tools in developing the object model. And finally, we explain how to organize an object model. Now, what I want you to specifically focus on, okay, and you'll have to focus very, very coherently in this particular set of lecture notes, because this is not going to be simple. It's going to be confusing for most of you. And just in case if you're not able to understand it well, you can always write me emails, you can ask questions, or what I would suggest is another simple and basic way to understand this concept is to read them quite a number of times, then you'll get used to the concepts. I have tried to make the notes as simple as possible to avoid any major forms of confusions. Now, overview of object-oriented analysis. OO methodology is popular because it easily or integrates easily with object-oriented programming languages such as Java, Smalltalk, VB.NET, Python, and Perl. Programmers also like object-oriented code, or O would stand for object-oriented code, because it is modular, reusable, and easy to maintain. The end product of object-oriented analysis is an object model. Object model represents the information system in terms of objects and object-oriented concepts. Now, if you would basically, now let me try to summarize it in simple terms. The term object-oriented methodology, what it does, it is one of the popular ways of easy integration with almost all of the popular programming languages. Now, not any form of programming languages, object-oriented programming languages. What is the difference between those? Now, if you look at Java, it is an object-oriented programming language. And if you look at C++, it is a non-object-based programming languages. Okay. Moreover, when you are using object-oriented programming languages, what happens is with the use of object-oriented methodology, it's reusable. That means you can reuse the code. It is easy to maintain, and it is modular. Another word for the word modular that I could think of at the moment is it is scalable or it is flexible. Okay. And with the implementation of object-oriented methodology, you generally come up with the end product called object model. Now, object model, it represents the information system in terms of objects and object-oriented concepts. Now, in order to actually understand object-oriented methodology or object-oriented model, first of all, you need to understand what is object. Okay, now object is not almost anything that you see around in comparing terms. Okay, objects are the things that you think of first in designing a program. Okay, for example, if I have to design something, if I have to design a program, I need to ensure or think of few things that I should begin with when I have to design a program. So with the concept of object model, what you do is you come up with the diagram, and using the diagram, uh, using the diagram, you try to think of how the system would look, how the system would communicate, and how the users will interact with the system. In other words, it's just a simple way of, how we had done per chart. We have seen following a critical path. So likewise, you do it for a system. You have a user will, let's say, place an order. After the order is placed, it goes to the factory, the product is developed, and the product is packed. After it's packed, it goes to the sales team, and the sales team then ends up delivering the product to the customer. So it's a process. Now, showing that in form of a object model would be drawing boxes and feeding in details how data would flow from one end to the other in an information system. Moving on, object-oriented terms and concepts. So the first one that we look at is Unified Modeling Language, UML. Now, we did look at UML last week. It is just a way of recapping and also adding knowledge to it. Now, UML, it is a method of visualizing and documenting an information system. Now, this definition would be way more easier to understand after we have known what objects are. So what are objects? Basically are the things that you think of first in designing a program. So when you are trying to come with a program, or when you are trying to come up with the information system or build a program, so what you do is you'll have to make an object model. So how is the object model made? Through the use of a UML, method of visualizing and documenting an information system. Remember, these are all interconnected. Okay, so object model, how is it derived? It comes from a UML. UML is just a method in which you can visualize and document how an information system would work. Now, attributes. So what is attribute? Okay, now attributes, basically, remember, we are looking at object-oriented analysis. So one of the first object-oriented terms and concept that we had looked at was UML. After that, it's attributes. Describe the characteristic of an object. The number of attributes required depends on business requirements of the information system, requirements of users. Attributes of an object are defined during the system development process. So attributes, basically, it describes the characteristics of an object. So if I have said that sales is one of the objects in my information system, so the attribute will actually go around and describe the characteristics of sales process in that object model. Moreover, your attributes are dependent on business requirements. That means what all are the requirements of the business, and taking into consideration the requirements of the users as well. And moreover, we need to know that attributes of an object are defined during the system development process. All right, so far we have looked at object-oriented methodology, and through it comes an object model. By the way, please put a note somewhere near object model. This is important. Through object model, or because of object model, we are derived to some object-oriented terms. And one of the terms is UML, Unified Modeling Language. So there's another important thing that you need to know, UML. Another term related to object-oriented is attributes. So what are attributes? It describes characteristics of an object. Also note down, please, what attributes are. After the term attributes, we have another term called methods. Method is also part of the object-oriented modeling phase. Okay, so methods, specific tasks that an object can perform. Remember, objects Okay, what are objects? Are things that you think of in designing a program, okay, and is done through the use of UML. So methods are specific tasks that an object can perform. And with it, it identifies all the functions that are performed and describes the functions performed. So if I have to sum it up, method is basically a specific task that an object needs to perform, and how it is performed, it is all listed in methods. So if you look at a method in form of a diagram in slide number 7, the bottom left corner, you see a method is more fries. So that is a specific task within an object. Now the object over here would be is what? So object can be, okay, the object can be is or customer ordered fries. So the method is more fries, and it should describe the function performed. Look at the third point. So it describes step 1 is heat oil, fill fry basket with frozen potato strips, and then lower basket into hot oil, check for readiness. When ready, raise basket, let drain, pour fries into warming tray, add salt. So method are specific tasks that are performed within an object and also describes how the task is performed. So methods definition, please do note that down. This is important as well. After that comes message. So we looked at UML, attributes, method, and now message. So message is a command that tells an object how to perform a certain task. Okay, it's just a simple command that tells the object how to perform certain tasks. And these certain tasks may be specific tasks with the specific steps. Polymorphism, concept that a message gives different meaning to different objects. Now we have some objects defined over there. We have an object for parent, dog, and child. Now polymorphism means is a message may mean differently to different objects. For example, when we say good night, okay, so a parent would think is time for read a bedtime story for the kids. When you say good night to a dog, the good night may think, or the dog may think the good night would mean is to cause the dog object to go to sleep, whereas child is to just get ready for bed. So those that simple message good night is interpreted differently for different objects at a specific point in time. And what is that called? It's called polymorphism. Okay, but what I need you to take a note of and to know it well is message. Now next term in object oriented is classes. Okay, an object belongs to a group or category called a class. All objects within a class share some common attributes and methods. Subclasses are categories within a class. Superclass, a class belonging to a general category. Now classes is basically, it is something where a group where objects belong to. Okay, so you have a group and objects belong to that specific group. These are called classes. For example, if I would go back to slide number 8, okay, so your object over there is parent, dog, child. Okay, now if you can group all three of them together, okay, they would belong to a specific class. Okay, for example, if I have to group them together, for example, if I have to group parent and child, I would call them human, whereas dog can be classed under animals. Okay, so that's what classes are about. Subclasses, when you have categories within a class. For example, we've just mentioned human. So human, either adult or kids. So parent would go under adults, the child would go under kids. Superclass, a class belonging to a general category. So this would be in terms of you have a class whereby a class could be for a general category. For instance, if I have to mix animal and humans together, okay, I would say living things. So living things, animals, parent and child, okay? Dog, parent and child, all of them will be combined, will be collected and put into this specific category. So that is called as a superclass. Now, relationship between objects and classes. If we look at the general term of relationship, okay, general, now forget about this, what you have on the slide. General definition of a relationship is whereby you have a connection with someone. And if you think of relationship, most basic way that I think of, or the very first thing that comes in my mind when I think of relationship, is you relate to someone in form of kinship, or through the use of friendship, or through the use of legal relationships. Okay, so that is what is very similar to we have in objects and classes. So relationships enable objects to communicate and interact as they perform business functions and transactions. Describe what objects need to know about each other. So relationship here means the interconnection between objects and classes, and how one object is related to another and how they communicate or interact with each other. For instance, we have two objects, parent and child. So how do they communicate? So what is the relationship? So the relationship between parent and the child is, the parent is basically, the parents are the one who basically gives commands, or basically they say something and the child has to listen. Okay, and how they communicate with each other, that is how relationships are defined. So looking at inheritance, the strongest relationship enables an object to derive one or more of its attributes from another object. So like mentioned there, with inheritance, it is the strongest relationship. It communicates and interacts with each objects. Sorry, it communicates and interacts with other objects. One or more attributes derived from another object. So that is what inheritance is about. Now, how are they similar? They're all, now the similar thing is relationship, we say connection or interconnection. Inheritance cannot be formed unless and until you have a relationship first, because you cannot have objects, one or more objects derived from another object unless and until there's any form of relationship. So there's a diagram there of relationship among objects and classes. Okay, uh, let's skip this for the moment. Why? Because when we actually go down in making use cases, I'll explain it to you easier. It will be difficult for me to explain it to you like this because it would definitely make no sense to you. So let's skip this particular diagram. Once we actually go to use cases, then I will explain you in simpler terms and make it more and more easy for you. Next up is object relationship. Now, object relationship diagram displays objects and how they interact to perform business transactions, business functions and transactions. So this is a simple diagram. In other words, what this diagram shows is basically it displays how objects they communicate or interact with one another, and what all business functions and transactions are actually performed. Okay, so do just know the definition of it. Do not worry about making a diagram. Okay, just know the definition of object relationship diagram. Now, object modeling with the unified modeling language. Now, UML uses a set of symbols to represent graphically the various components and relationships between a system. True. Now, if you look at the definition that we looked at for UML, we said visually showing your information system and the interaction between the objects within the system. So how does UML do it? Is through the use of certain symbols and the use of certain objects. Now, use case modeling. Now, this is a common type of UML diagrams that you learn and what is actually practiced in the industry. And this is what we'll be doing it after the break. The very first lab that we'll be working on is on use case modeling diagrams. Now, use case, represents the steps in a specific business function or process. An external entity called an actor initiates use case by requesting the system to perform a function or process. Okay. Now, with UML use case, and generally it's called as UML use case or just use case, you can call it. Okay, but mostly you'll see it over the notes. You also see it even in exams question or multiple choice questions that it is referred to as UML use case. So UML use case diagrams in simple terms provides a step-by-step list of the tasks and other key descriptions and assumptions. And when you look at a UML use case diagram, okay, let's read the next slide and I'll explain it further to you. So UML symbol for a use case is an oval with that a label that describes the action or event. The actor is shown as a stick figure with a label that identifies the role. Use case description documents the name of the use case, the actor or description of the use case, provides a step-by-step list of tasks and other descriptions and assumptions. So in use case, you have somebody called as a actor. A actor is someone who basically interacts with the system. So the actor can be a person, it can be in form of another system, or it can also be an external entity. Okay, now what those are and how they do it, you'll actually learn it in much more detail when we actually go around making use case diagram. So why are we discussing this then? Why we're discussing this is just for you to learn the definition of what use case is. Once you actually know the definition of what use case is, okay, when you go around making it, it will give you better enhanced understanding of how things will be done, because making use case diagrams are not easy. Okay, so definition again for use case, okay, provides a step-by-step list of tasks and other key descriptions and assumptions. Now, the use case diagrams are visual summary of related use cases within a system or subsystem. Now, why it is called use cases? Because it presents a diagram in which how the system is going to be used in different scenarios in terms of cases. So that's why it's called use cases. How system or systems will be used in different scenarios, use case. The first step is to identify the system boundary, which is represented by a rectangle. System boundary shows what is included in the system inside the rectangle and what is not included in the system outside the rectangle. The system boundary is represented with the use of a rectangle. So whatever is within the system is basically, it shows you what all is included in the system. And whatever is outside the rectangle, it tells you what is not included in the system. So system boundary represented by a rectangle, it gives you a visual summary of the system, okay, and it also shows you what is included and what is not included in the system. Okay, you don't need to worry about the definition of system boundary. It is just there for you to actually learn how to go around creating a use case. So once okay, pardon me, I think we had some connection issues. Now we are back. I hope you're able to hear me. If you're not, do let me know. Now, going back, we were discussing on system boundary. So this is an example of how system boundary is actually displayed. So this specific rectangle in blue, the borderline of the rectangle represents, and what is inside it includes the system. So what you're seeing in the rectangle, okay, is what is within the system, okay, and what things are included, and what you're seeing outside the rectangle are those things which are not included. These stick figures, they represent the actor. So the actor would be an either an internal actor or an external actor. Now, what internal and external actors are, how they communicate, why they communicate, and for what reasons they communicate, we will be looking at them when we actually go around creating a use case diagram. So far, what I need you to learn is what use case diagrams are. Just know what a system boundary is, what an actor is. Okay, now there's hardly a case where these definitions are actually asked in the exams. So, and also I do not want to put an emphasis whereby you're just learning definitions to actually answer questions in the exams. We're actually doing it so that you learn. Okay, so do know what boundary is, what actors are, and what is the main purpose of use case diagrams. Slide number 17, class diagrams. Show the object classes and relationships involved in a use case. Each class appears as a rectangle with the class name at the top, followed by the class's attributes and methods. Lines show relationships between classes and have labels identifying the action that relates the two classes. Includes a concept called cardinality. Cardinality describes how instances of one class relate to instances of the other class. So in general and simple time, when you're looking at a class diagram, what a class diagram does, it shows the object classes and the relationship involved in a use case. So it's very simple. It's just like saying is you have a set of objects, okay, and the objects is defined through the use of a class. Remember classes? Classes are basically group of objects. So a group of objects, you have it in a use case, and you show the relationship between the two of them. So, or more of the objects that you have. So that is generally defined by class diagrams. Now, I would generally label this as not so important because our focus for CIN603 is only on one or two specific UML diagrams, and one of it is use case. So class diagrams, just generally know what the definition is and know what they do. And this is an example of a class diagram. So what happens here is you have one object and one object, sorry, you have one class here, employee, and how the class is connected to the object, okay? And the nature of the relationship, you have 0 to many, 0 to 1, 1 and 1 only, 1 or many. Now, don't worry about this, okay? This is for general information. Sequence diagram. It is a dynamic model of a use case showing the interaction among classes during a specific time period. Graphically document the use case by showing the classes, the messages, and the timing of the messages. Include symbols that represent classes, lifelines, messages, and focuses. Now, for sequence diagram, the simple way in which you can define is it shows the interaction. Okay, it shows the interaction among classes during a specified period of time. So when you are making a use case, okay, so what happens is, because since use case is such a complex diagram, okay, to simplify things, you can make even a sequence diagram. And what the sequence diagram shows is it shows interaction among classes during a specified period of time. This is general knowledge. Just keep it there for general knowledge, okay? Such things are not going to be tested in exams. Object modeling with the unified modeling language. So you have a sequence diagram shown. So if you look at the sequence diagram, you have a class, two classes, class 1 and class 2. So with the classes, you also have objects. Now, these are objects, okay? And how the objects, they interact with one another and at what specified time. So lifeline is basically the time. State transition diagrams. State transition diagrams show how an object changes from one state to another depending on events that affect the object. All possible states must be documented in the state transition diagram. States appear as rounded rectangles with the state names inside. Now, with state transition diagram, it shows how an object changes from one state to the other. Now, if you look at new is an object over there, active or existing is an object, frozen is an object, closed or former is an object. Now, this entire example has been picked up from a banking system. So what happens is there's you. So you are trying to come up with a new account. So new becomes your object. So once you make your very first deposit, your new account becomes active. Okay, meaning your account is not active. You can use it for future references, okay, or future purposes. So once your account is active, let's say you do not use it for a certain period of time, let's say about a year. So what happens? Your account is generally frozen. Okay, you must have noticed this. You could have had a bank account, you didn't use it for a while, so the bank freezes it. Okay, what happens is when they freeze your account, you are not gaining any interest. At the same time, you're not paying any interest, so it's frozen. Now, to actually now if you look at this, from new to active, that's a change in object. So there is a state transition. Transition means something moving. State means current point in time. So your current point in time, your state transitions from new to active or existing. Moreover, if your account is frozen, so your state moves or it changes from active to frozen. Let's say it's frozen, and then you go back to the bank again and then reactivate your account, so it becomes existing. So from active, it was frozen, and from the frozen state, now it has changed to existing. Let's say if it continues for some time, and then what happens is you realize that you do not need the bank account. Probably the bank is charging a lot of taxes. They have a lot of additional or hidden charges to it. You say you want to close the account. So from active, you go and move from that particular object to closed or former. So you're closing your account. Okay. So when you're closing your account, so that's moving from one object to the other. Now, generally, when you close your account, the bank will keep your account for a certain period of time, sometimes a year, sometimes more, thinking it, what if the customer comes back or wants to open up a new account? So they will again have it in the state as frozen. So this is what the state transition diagram shows. It shows how an object changes from one state to the other. Now, activity diagrams. Activity diagrams shows actions and events as they occur. Show the order in which the actions take place and identify the outcomes. So with the activity diagram, okay, it, like the first point says, it shows actions as the event occurs. For example, the object is customer insert an ATM card. Okay, so you will have to display the object. Activity this is the very first activity. Okay, customer needed cash, so the customer inserts the ATM card. So the card is accepted. Now that is the flow of data. So the card is accepted. After your card is accepted, what you generally do is in an ATM, you enter your PIN number. So that's another object. So from that object, okay, once that is accepted, the customer requests in cash. And after that, so the customer checks the balance and then gives the cash, or what happens is the customer directly enters the amount and he or she is provided or told that either they are sufficient or insufficient funds. So that's an activity diagram. So what it does, it shows the order in which activities take place and then identifies that specific outcome. Okay, now if you try to imagine or visualize this, it's pretty simple. It's just a diagram which shows what all things take place when you are using an information system. So in the diagram, which is shown there on this slide number 22, it shows an activity diagram of an ATM. Business process modeling, BPM. Business process modeling basically represents the people, events, and interaction in a system. Can be used anytime during the system's development process, compatible with object modeling. Now, BPM, the major purpose is that it shows the interaction between people, and the system and all the events that take place. In other words, when you are in other words, when you are getting a business process modeling done, is just a diagram, okay, or it's just a process in which you show the interaction between the people, the system, and all the events that take place. And a very good example of BPM again is a use case diagram. So what happens is that in a use case diagram, first of all, you show the system that this is how the system is, and then you have different cases in which the actors, they communicate with those cases. When we say cases, scenarios. So you have, let's look at the bank, for example. So the actor in a bank, you have a customer. So a case would be is check balance. So the actor interacts with the system to actually go and check balance. Moreover, you have a bank as an actor as well. So that is an external actor. So the bank is an external actor. So what the bank does is the bank also communicates with the system to ensure that all necessary maintenance is done and people are able to get the service that they actually pay for. Okay, so this is what could also be derived in a business process modeling. And an example is shown through the use of Microsoft Visio. Okay, you have a Visio. This is, yeah, it's Microsoft Visio. Okay, so through the use of Visio, you are showing a business process model and how each and every client or actor, in other words, they are interacting with one another. Okay, and how the people and the events also interact with one another. Now, object modeling with the unified modeling language, case tools, provide an overall framework for documenting the system components. Object modeling requires many types of diagrams to represent proposed systems. Case tool speeds up the process, ensure consistency, and provide links. Once objects are described and used in one part of the design, they can be reused multiple times without future effort. Now, case tools, these are basically software applications. Software, they mean the same thing, by the way. Software or applications that allow you to go up and document an information system. Now, documenting information system here can be either in terms of visual documentation or in just documenting in terms of texts. Okay, so with case tools, what happens is you can draw up many different forms of diagrams to represent the proposed system. Now, why use case tools? Now, you can also get it done through the use of pen or paper. You can also get these systems done to the use of Microsoft Word or Excel or PowerPoint even. Okay, it's easy to draw boxes, easy to draw ovals and rectangles and show arrows. Not difficult at all. But what happens is that with use case, it speeds up the entire process. Why? Because instead of you actually manually drawing a rectangle, manually drawing an arrow, what happens is you can go around, click on objects, click and drag, and easily are able to build things. Moreover, it also ensures consistency. Consistency in terms of when you're doing in Microsoft Word, one box may be bigger, one box or rectangle may be smaller. Your actor, just imagine if you have to create an actor in Microsoft Word, actor is represented by a stick figure. So you have a circle and then 4 lines connected to it. There's a likely chance most of the time that when you scroll your document up and down, your symbols will move from its current spot. So what happens with case tools? These are softwares that provides you with a level of consistency and also ensures that the entire process is speed up. Moreover, case tools also provide you with the flexibility to go around changing things. Let's say you have done or you have drawn a diagram, okay, a use case diagram using a case tool, and later on, if you would like to go around changing or editing it, changing it in case tools would be very, very easy. Whereas if you use a software like Microsoft Word, it becomes very difficult. So that's the purpose of case tools. Now, organizing the object model. Develop an object relationship diagram that provides an overview of the system. Now remember, the the main purpose of object relationship diagram is to actually show an overview of the system. That means just by looking at the diagram, you are able to determine what the system will do, what will be your input, how it will be processed, how output is produced, where and how it will be stored, and how people are actually able to interact with the information system. Support each diagram or object definition with clear and relevant documentation that can be accessed easily. Organize use cases and use case diagrams so they can be linked to the appropriate class, state, transition, sequence, and activity diagrams. Maintain accuracy. Now, you must know this is when you are creating use case diagrams, okay, some of the complementary diagrams they can also come up with is class, state transition, sequence, and activity diagrams. So what happens is that some of those things which may be too difficult to show in the use case diagrams, you can show it in the other diagrams. However, they're not compulsory. You can show use case diagrams, okay, and then still include each and every detail. However, if you want to give it more information, break it down into tiny, smaller parts, that's where you have these other diagrams coming in. Chapter summary. Object modeling is a popular technique that describes a system in terms of objects. Object-oriented terms include classes, attributes, instances, messages, and methods. Objects can send messages or commands that require other objects to perform certain tasks or methods. The UML, or Unified Modeling Language, is a widely used method for visualizing and documenting an information system. Use case describes a business situation initiated by an actor. So the actor is going to be a person, is going to be a system, okay? Internal, external actor who interacts with the information system. At the end of the object modeling process, the use case and the use case diagrams are organized, and class, sequence, state, transition, and activity diagrams are created. And that finishes up our slides. Going back quickly, okay, to the entire set of notes, please do note down the important things that I want you to know of, and those things which are in a likely chance of being tested in the mid-semester exam. Okay, you should know what an object model is. Okay, first of all, what is an object model? So when you look at object model, okay, so object model has certain terms, it has certain concepts. Now, some of those terms are attributes. Do know what is an attribute and how it contributes to the object model. Second is methods. So what is method and how again it contributes towards the object model. If you just know the definition, you should be able to get the answer as to how it relates to the object model. After methods, you have message. What is message? And again, what part does it play in object models? Do know what are classes. Don't worry about subclasses and superclasses. Just know what classes are. This is important, the relationship and inheritance between objects and classes. What is a relationship? A relationship is how it communicates and interacts with one another, the interconnections between the objects and the classes. Inheritance. So inheritance basically enables an object to derive one or more of its attributes from another object. And also note that you cannot have an inheritance unless and until you have a relationship first. Object relationship diagram, just know the definition of it, okay? Now, when you talk about object relationship diagram, from it comes UML diagrams, okay? When you talk about object relationship diagram, from it comes UML diagrams, and use case is a type of UML diagram. So know what is UML and know what is use case. Finally, what I want you to focus on is what are teach tools and what are some of the advantages of using case tools. Let me repeat that. Focus on what are case tools and some advantages of using case tools. Okay. When I say focus on is look at the definition. Why do we use case tools? What purpose is it there for case tools in object modeling and so forth? And that's it. So that finishes up our lecture slides for week 6. Now the lecture slides initially they were quite big. I've tried to make it as small as possible so that it becomes easy for you to revise. 1, 2, so that you don't confuse yourself, knowing that this is quite new for most of you. Okay, because these are some project management techniques and terms which tend to confuse students. Now, going back to our mid semester. Okay, so for the mid semester, what all I'm focusing on is everything from week 1 till week 6. Okay, so go over your lecture 1 quiz. Okay, all the quizzes. I'm sure the preview is already there. You should be able to go and preview your attempts if you've attempted. If you have not attempted, okay, you need to attempt it, only then you can view your preview. So those who have not attempted, you are at a losing side at the moment. Okay, so all the lecture 1 quiz from week 1, all the lecture quiz from week 1 to week 6. Also, please go over your tutorial questions, learn them well, especially with the short answer questions. And finally, another place where I am testing you is generally all the important things that I have been alerting you while we're discussing the lecture notes. Now, do realize this. Your mid-semester exam will open up on Sunday, coming Sunday. Now, if you think you do not need additional revision, please go ahead and attempt your mid-semester exam. You're provided with 1 attempt only, by the way. That means if you attempt it once, you have to attempt the entire thing of multiple choice, short answer questions, and object modeling. And if you feel that you're not ready and you need to go through the revision, so the revision classes will be held accordingly next week, Monday from 12 to 2 p.m. Okay. And also on Thursday, 10 to 12 in our tutorial class. So we will definitely go over our revision class. Now in the revision, what will happen? I will provide you with a set of questions in your revision class, and you will need to answer those questions on your own. Okay, I will not provide you with the answers. I will provide you with questions though. Now how many questions? It depends. If your lecture notes has a lot of concepts, so I will be giving you questions of all the important concepts from your lecture notes. So by Monday, close to about lecture 1 to 4 will be covered, and by Thursday we will be covering up 5 and 6, because 5 and 6 are quite small lectures. So please do join us in for tomorrow's class, from next week's revision classes, Monday and Thursday, and you'll go over the revision. But like I've said, if you feel that you're prepared, you can do the mid-semester exam without any revision questions, you're most welcome to go ahead. Okay, so that's on the lectures for week 6. Also, that's all for your mid-semester exam. Your major project, okay, like I mentioned in the last few weeks, it's not easy. Okay, you have to do a lot of work. If you're someone who's thinking of doing the project alone, you need to start your project as soon as possible. If you're doing in pairs, that's good, but you also need to start, because that actually cuts short an individual, because this entire project is specifically designed for 3 people. Okay, 3 of you to handle things. And those of you who are grouped in 3, okay, that's also for you to start it as soon as possible. Probably as soon as you finish with the mid-semester exam, get on with it. If you can finish it in the mid-semester break and submit it to me within the break, that's even better. It eases off your load for the next few sets of weeks that will come after the break. Why? Because you'll have assessments in other courses as well. Yep, so that's all for the major project. Your weekly quizzes. Now your weekly quizzes, the number of attempts is quite low actually. If I would look at from week 1 till week 5, the maximum number of attempts so far from all the 5 weeks is just about 5 or 6 students. And the remaining, we have close to about 15 students in the class. The remaining, you are still waiting on for probably 31st of October. If you are one of those, I would suggest is you are at a losing end come next week. Why? Because you will not be able to revise your lecture-based quizzes unless and until you attempt them. All right. And moreover, those quizzes, okay, those quiz questions are different for each and every one of you. How and why? Because what I've done is I've not put in simple 10 questions only, whereby all of you are given the same set of questions. Now, I have put up a question bank. A question bank is basically just like you have bank where you put in all the money and then take out few of them or take out some specific amount. Likewise, a question bank is just a repository or a database whereby you feed in abundant amount of questions, and randomly in your quizzes 10, 15 or 20 questions depending on what it is configured, only that number of questions would pop up. So if you want to revise well, I would say get hold of your friends, compare which questions you have and they have, and see which questions you don't have specifically, and try to work on them as well. In that way, it will make your work a bit more easy in terms of revising, in terms of your revision coverage is quite higher. For your tutorials, uh, those of you who have been writing down the answers in the tutorial classes, that's a plus point for you. Those of you who have been waiting for the tutorial videos, like I mentioned earlier, I will not be giving you sample answers apart from what I'm discussing in the tutorial class. Those of you who have not been writing down the answers in the tutorial class, or have not been attending the tutorial class, or have not been even going through the videos that are placed on the Moodle shell for the tutorial classes, this is the time where you will pile up a lot of work, because you'll have to go through the individual videos. Now, one video is close to about 1.5 to 2 hours. Sometimes we have finished early in terms of 1 hour 15 minutes. Sometimes we've hit the exactly 2 hour mark. So there's a place where you will have a lot of work to cover. So, and people who have the questions with you, okay, or sorry, the sample answers with you, please carefully revise your short answer questions as much as possible. Moreover, the matching questions and some random multiple choice questions which are there, also revise them. You never know, probably a multiple choice question is formed from a matching question. Okay, the concepts are same, the coverage is same. Yeah, so that finishes up week 6 of our syllabus. Now week 5, week 6, the syllabus is quite low, which is a plus point for you in terms of the lecture loads is quite less. Okay, your tutorial questions are there, okay, which is quite less as well. So that is a plus point, giving you more time for your revision. So as soon as you get time, please start working on your revision. Those of you who are doing 3 and more courses, you'll have to amp up yourself in such a way in which you are able to manage your time more. All right, any questions, any queries from anyone? No questions, no queries? If no questions or no queries, this is where we'll break off the class for today. So thank you very much everyone for joining in. Please keep up with your revision for your mid-semester exam. Attempt your lecture-based quizzes as well. Those of you are still waiting for the tutorial classes to be finished, please start revising your lecture 1, 2, 3, 4, and 5 quizzes. Train yourself very, very well. Dedicate time. Probably one day you can go over the lecture-based quizzes. The next day you can go over tutorial matching. The following day you can go over your tutorial short answer questions, have them summarized, make short notes in one way or the other, and then dedicate probably about 1 hour per day for you to actually note down all these important things from the lecture notes and write it down somewhere. And then by the end of the week, by Thursday or Friday, you should have a set of summarized notes. So go over those notes over and over again. So as much as you go over them, you'll start learning them and you'll start knowing the details in those summarized set of lecture notes. Okay, so yep, that's all from my end. Thank you so much everyone for joining in. I hope all of you are safe. So stay well, ensure that you continue keeping yourself as safe as possible, and please, if you get time, do get yourself fully vaccinated. So thank you very much. See you all in the Thursday's class. Thank you.